Okay, so this lesson is going to be about converting grams to moles or going the opposite way. And anytime you do that, you're going to be using the molar mass. Okay, so that's what we learned last class. But before we get into that, I think we need to talk about how to go from moles of a compound to atoms of just an element inside the compound. So in this problem, we have how many atoms of oxygen, so that is atoms of just one element, are in 2.3 moles of carbon dioxide. So this is a compound with oxygen inside. Okay, so we need to start with what we're given and then find our goal and find a way to get there. So we are given, let me erase this, oops. We're given atoms. We're asked for how many atoms of oxygen are in 2.3 moles of carbon dioxide. So again, the numbers is your goals, given. So the numbers is your given, so I have 2.3 moles of carbon dioxide. I'm asked for how many atoms of oxygen. So my goal is question mark atoms of oxygen, okay? So you have to recognize that you are given carbon dioxide and you're asked for atoms of oxygen. So the first thing that we have to do is figure out how many molecules of carbon dioxide are in 2.3 moles of carbon dioxide. Okay, so we're going to go from moles of carbon dioxide to molecules. Okay, so pieces of carbon dioxide. And once we have pieces of carbon dioxide, we can then figure out that per every carbon dioxide, how many oxygens do you have right there? Okay, so one carbon dioxide, I have 2 oxygens. So that's going to be our plan. So like every time we start with what we're given, we're going to start with 2.3 moles of carbon dioxide. Okay, and we're always going to use some type of conversion factor, so we're going to multiply it by a conversion factor to get away from the moles. So if right here moles is on top of this imaginary 1, then I need moles to go on bottom of the next fraction. So it's going to be moles of CO2. So I know that 1 mole of CO2 is equal to 6.02 times 10 to the 23rd molecules of CO2 or pieces of CO2. Okay, so that did get me that got rid of the mole of CO2 right here, but it did not get me to my goal. Okay, so I'm not at atoms of oxygen yet. So that means that I need to keep going another step. So if I need to keep going, that means that I want to say molecules of CO2 on the bottom of this fraction so that it will cancel with the one on the top of the other one. Okay, so if molecules is at the top over here, has to go at the bottom of the next fraction. Even if I really don't have a clear route, I still need to put it at the bottom so that I can put something that is equal to 1 molecule of CO2 at the top, okay? So we've gone from moles to molecules, so we've done this step. Now we just need to go from molecules of carbon dioxide to atoms of oxygen, okay? So this is what we are going to use. We're going to use a ratio right here. Okay, so we know that 1 carbon dioxide atom or molecule has how many oxygens? Okay, you can see right here that it has 2 oxygens. So 1 molecule of carbon dioxide is going to have 2 atoms of oxygen. Okay, so now we have canceled out all of our units beside atoms of oxygen. Okay, that just happens to be our goal. So when we get our goal on top, we are going to put an equal sign and solve for atoms of oxygen. Okay, so in our calculator, it will look like this. We will say 2.3 times, open parentheses, 6.02 times 10 to the 23rd, close parentheses, times 2. Okay, let me do that. Okay, I got 2.7692 times 10 to the 24th. So 2.769 times 10 to the 24th. I'm going to round that to 2 sig figs. So it's going to be 2.8 times 10 to the 24th atoms of oxygen. Without the atoms of oxygen, it is wrong. Okay, so let's just look back at that again. We were asked for how many atoms, of oxygen are in moles of carbon dioxide. So the first thing we did was go from moles of carbon dioxide to molecules of carbon dioxide. Once we got to molecules of carbon dioxide, we could go from molecules of carbon dioxide to the ratio of how many atoms of oxygen are in that, okay? So if we were doing a problem that had, say we had moles of silver nitrate, okay? And I asked you how many ions of silver were in there. So you would go from moles of silver nitrate to molecules, or since this is a metal, non-metal, it's going to be, actually, instead of molecules, it's going to be units. So you're going to go to units. Again, this is just pieces, so like pieces of silver nitrate. So once you go to pieces of silver nitrate, then you can say every piece of silver nitrate, so every time I have like 1 silver nitrate, I have how many silvers? So you can go from units of silver nitrate to units of just silver, okay? So in this situation, every 1 silver nitrate has 1 silver. So this is a 1-to-1 ratio. So you wouldn't actually multiply by anything greater than 1, okay? So I think that is all I have to say on that. So let's go back to our initial goal. We were supposed to be talking about grams to moles, so let's do that. So let's stop with that. If you still don't understand, please rewatch, or we can try a different way on this stuff up here.